Imagine a world where continents were drowned, vast shallow seas stretched across what is now dry land, and giant reptiles patrolled warm, tropical oceans. This was Earth during the mid-Cretaceous period, roughly 100 million years ago, a time of unprecedented global sea levels. It was a hothouse Earth, an era that dramatically redefined our planet's surface and the life it sustained. During this extraordinary epoch, global oceans rose an estimated 200 to 300 meters above modern levels. This wasn't merely a minor shift, it was a planetary transformation. This extreme highstand reshaped landmasses, altered global climate patterns, and engineered entirely new ecosystems on a scale we can scarcely comprehend today. Several powerful forces conspired to produce the Cretaceous highstand, leading to the highest sea levels ever recorded in our planet's history. First, global temperatures were significantly warmer, meaning there were no major polar ice sheets to store water. This colossal volume of water remained in the oceans. Second, the thermal expansion of seawater played a crucial role. As the oceans warmed, the water molecules themselves expanded, physically increasing the total volume of the oceans. This subtle yet powerful effect contributed substantially to rising sea levels. Third, high seafloor spreading rates during this period were a major driver. Young, hot oceanic crust is less dense and therefore rides higher on the Earth's mantle than older, cooler crust. This uplifted ocean floor displaced vast quantities of water upward, contributing to the inundation of continents. Fourth, related tectonic activity led to shallower ocean basins overall. The combined effects of rapid spreading and other geological processes reduced the capacity of ocean basins to hold water. Finally, the accumulation of sediments on the seafloor further reduced the ocean's volume, pushing even more water onto the continents. The most dramatic consequence of these rising waters was the partial submergence of continents. Up to 1/3 of what we now consider modern landmasses was underwater. This created a world where shallow seas, known as epicontinental seas, spread far across continental interiors. One of the most famous examples was the Western Interior Seaway, which famously bisected North America. This vast inland sea created new marine habitats and divided terrestrial animal populations for millions of years. With a warm climate, mountain ice and erosion were significantly reduced, leading to lush lowlands even in regions that are now temperate. Coastal ecosystems, including beaches, mangroves, and deltas, were pushed hundreds of miles inland by the encroaching waters. This constant shifting forced both plant and animal life to adapt or perish. The estimated global ratio during this time was approximately 70 to 75% water and 25 to 30% land, a stark contrast to today's approximately 71% water and 29% land. Life on Earth responded to these dramatic changes with remarkable adaptability and diversification. Tropical forests expanded poleward, thriving in the warm, humid conditions that allowed palms and conifers to grow near the planetary poles. This widespread vegetation fueled diverse terrestrial ecosystems. In the newly expanded and warmer seas, marine reptiles diversified into an astonishing array of forms. Mosasaurs, plesiosaurs, and giant turtles dominated these aquatic environments, becoming apex predators and shaping oceanic food webs. Meanwhile, dinosaurs, though confined to shrinking landmasses, continued to thrive. Iconic groups like hadrosaurs, ceratopsians, and titanosaurs adapted to coastal plains and island-like habitats. They navigated a world of fragmented land, demonstrating incredible resilience. The warm, nutrient-rich seas also led to massive plankton blooms, providing the base for abundant marine life, including flourishing coccolithophores and ammonites. Estimates suggest a successful adaptation rate of approximately 60 to 70% of species persisting through the Cretaceous period. However, this stability came with a significant evolutionary churn, with an estimated 30 to 40% species turnover across the period, reflecting continuous adaptation rather than mass extinction. The warm, nutrient-rich shallow seas of the mid-Cretaceous were a haven for immense marine life. These conditions supported not only diverse populations but also creatures of truly colossal proportions. Giant marine reptiles and large fish became emblematic of this period, filling every available ecological niche. Among the largest sea creatures, Mosasaurus reigned supreme, reaching lengths of 50 to 56 feet as an apex marine reptile. The Elasmosaurus, a plesiosaur, was renowned for its astonishingly long neck, stretching up to 45 feet in total length. Kronosaurus, another powerful short-necked plesiosaur, commanded the seas at 30 to 35 feet. Even fish grew to enormous sizes, with the predatory Sphanctinus reaching 15 to 20 feet. It's estimated that sea creatures of the mid-Cretaceous were, on average, 20 to 40% larger than similar ecological roles occupied by animals today. This gigantism was likely fueled by the consistently warm waters and the abundant prey resources that flourished in the productive shallow seas. The Cretaceous greenhouse climate was characterized by profoundly different atmospheric conditions compared to today. It produced exceptionally high global humidity, creating a perpetually moist environment across much of the planet. This atmospheric moisture fueled intense monsoons, which delivered massive amounts of rainfall to various regions. Frequent tropical storms were also a common feature of this dynamic climate system. These weather events redistributed moisture and energy, contributing to the overall warmth and humidity. Rainfall estimates, relative to modern averages, indicate a significantly wetter world. Global precipitation is thought to have been 10 to 20% higher than today. In tropical regions, this increase could have been as much as 30%. Perhaps most dramatically, polar regions, lacking ice caps, were dramatically wetter, supporting lush vegetation where today we find barren ice and snow. These figures are derived from sophisticated climate models, as direct percentages cannot be confirmed through fossil records. Did Homo sapiens exist then? The question of human existence during this ancient era is an important one. The definitive answer is no, humans did not exist during the mid-Cretaceous period. Homo sapiens, our own species, appeared only about 300,000 years ago, an incredibly recent event in geological time. The mid-Cretaceous ended 66 million years ago, a vast chasm of time separating us from that world. During this period, not only did primates not exist yet, but early mammals were typically small, nocturnal, and often rodent-like in their appearance and habits. The lineage leading to humans was still many tens of millions of years in the future. On land, the mid-Cretaceous was the heyday of dinosaurs. Dominant land animals included powerful tyrannosaurs, although the famous Tyrannosaurus rex appeared later in the period. Vast herds of hadrosaurs, or duck-billed dinosaurs, were common, as were the distinctive ceratopsians, such as Triceratops. The enormous, long-necked titanosaurs were among the largest land animals ever to exist. Alongside these giants, small mammals, often described as shrew-like, quietly survived and evolved. The plant life also showed significant diversity. Conifers and ferns were widespread, contributing to lush landscapes. Crucially, flowering plants, or angiosperms, were rapidly diversifying and spreading globally, changing the face of Earth's flora forever. Coastal regions were characterized by extensive mangroves and swamp forests, particularly in areas inundated by epicontinental seas. The seas teemed with life. Ammonites, shelled cephalopods, were incredibly abundant and diverse, often serving as key indicators for dating rock layers. Belemnites, squid-like creatures, were also prevalent. The warm waters fostered immense plankton blooms, forming the base of a rich marine food web. Of course, the iconic marine reptiles, including mosasaurs and plesiosaurs, were the undisputed rulers of these ancient oceans. While the mid-Cretaceous did not feature a single, catastrophic mass extinction event, it was a period of significant evolutionary dynamism. The constantly shifting coastlines and the creation of new, expansive shallow sea habitats led to high evolutionary turnover. This meant a continuous cycle of new species emerging and older ones adapting or disappearing. Over tens of millions of years, an estimated 30 to 40% species replacement occurred. This wasn't a sudden die-off, but rather a sustained period of ecological restructuring. One of the most significant changes was the rapid evolution and global spread of flowering plants. Their emergence fundamentally altered terrestrial ecosystems, providing new food sources and habitats. Marine ecosystems also underwent profound restructuring. Ammonites and marine reptiles diversified into an incredible array of forms, exploiting the expanded aquatic environments. This era highlights how environmental change can drive not just extinction, but also incredible evolutionary innovation and adaptation.